Good afternoon, everyone. Thank you very much for coming. I think I'm looking forward to this session probably as much as you are, or even more. So I'm Lynn Sullivan. I'm an architect and I'm chair of the Good Homes Alliance. And our mission is raising standards in housing, particularly new housing. And so, what better thing to be chairing this afternoon than our session on the Future Homes Standard. And as I'm sure you're aware, the original announcement from Philip Hammond was that we can expect by 2025 to have low carbon heating and world-leading energy standards of energy efficiency in our new homes. So the question is, well, actually there are three questions: when, what, and how. And hopefully our speakers will enlighten us all. So I'll introduce our speakers one by one. And I'm trying to leave about 15 minutes at the end for some questions, because I'm sure you'll have lots of them. So I'll introduce our speakers as they come up. And if you don't mind, I'll leave the questioning to the end, so then we can get them all and we can have a more interactive session. So first of all, I'd like to invite Dr. Victoria Tink from the Ministry of Housing, Communities and Local Government. And who's an environmental scientist by background. Victoria, thanks.
Thank you very much for the introduction. So I'm going to talk to you about the Future Homes Standard and how we're going to get there. So just a way of a little bit of background. Homes account for about a fifth of our carbon emissions, and in the summer we set a net zero commitment. We're going to be a net zero economy by 2050. If we want to get there, we need to do something about our homes. Building homes right now that are fit for the future is absolutely vital to meeting this aim. And that's why we have committed to introducing a Future Home Standard by 2025. Many of you will know we had a consultation open recently. It just closed on the 7th of February. We received an overwhelming number of responses, more than any previous Part L consultation. We think probably more than any previous building regulations consultation. Really, a lot of people replied. Well over 3,000 people have responded to us. We're working on the analysis of this and developing final proposals, but as I think you can appreciate, that's going to take us a little bit of time. So what is the Future Home Standard? Well, by 2025, we want homes to be extremely energy efficient and to have low carbon heating. So let's talk a bit about low carbon heating. We think there are probably three leading technologies for low carbon heating. Heat pumps are going to be absolutely essential in decarbonising the building stock. But also we think that heat networks are going to be really important as well. So heat networks are great in high density areas like cities, and they're great because they can decarbonise through time. Another technology we think is going to be important, but maybe not quite as important as the others, is direct electric heating. And we think that's got a role to play where the fabric is really well insulated and you need not very much space heating. We're keen that the Future Home Standard remains technology neutral, and that means that this keeps it open for innovation, such as perhaps hydrogen in the future. And we want to make sure that any low carbon technology is accompanied by really high levels of energy efficiency. And the Future Home Standard is intended to deliver 75 to 80% lower carbon emissions than our new homes right now. So let's talk about a little bit of context while we're talking about electric heating. As well as standards for new homes, there's a lot of work going on nationally, changes occurring in the electricity grid. So historically, the North Sea has been an oil and gas resource, but now there are actually quite a large amount of wind turbines there as well. And growing the capacity of renewables on the grid and moving away from coal in our power stations means that the reduction of the carbon intensity of our grid has really increased recently. If I show you a few... So this red line here is the carbon intensity of the grid when we last reviewed Part L. So this is around 2013, 2014. Second line, that's where we are now. So it's an absolutely huge difference in the carbon intensity of our grid between the last Part L review and now. It's more than halved. And we can expect this trend to continue as we get more and more renewables into the grid. By 2050, the grid needs to be around net zero. And homes built to the Future Home Standard will be really highly energy efficient and be really low carbon when they're built. They will also continue to decarbonise through time. And we're calling them net zero ready homes. So there'll be no need to retrofit these in the future. There's a lot of work to do to get to the Future Home Standard in 2025. One particular issue is skills. So there are around 800 accredited installers for heat pumps right now. If we want to compare that to the 135,000 gas-safe engineers we have, that is a huge amount of upskilling needed to change our industry from one that installs gas boilers and retrofits gas boilers into one that is ready to deliver heat pumps in new and existing homes. The scale of that challenge cannot be underestimated. So we need to work with the industry to make sure that we can transition to low-carbon heating. We can make sure that installers can upskill, supply chains can be readied for this change, and both those things will mean that we need to make sure we have really good quality installations, which are genuinely low carbon and good for consumers when they live in these homes. We need to work at pace to get there, but we can't rush this kind of work. So let's just talk about how we're going to get to the Future Home Standard in 2025. So the Future Home Standard consultation was all about what are we doing in 2020 to get us there. So we're proposing an interim step in 2020 to increase the energy efficiency of homes right now and make sure they're low carbon right now and to prepare us for 2025. And we presented two consultation options, option 1 and option 2. Option 1 is a 20% reduction in carbon emissions compared to our current standard, and the idea behind that standard is it delivers the fabric standard that we need ready for 2025. Option 2, which is our preferred option, that's an even more ambitious uplift, 30%, but it means that it should start encouraging people to install heat pumps right now, and getting those supply chains and the skills ready for 2025 is absolutely fundamental. So I'm going to show you some examples in a minute, but before I do that, I'm going to tell you a bit about the metrics we're using. So we are proposing to keep our carbon target as we do now. We're also thinking of introducing a primary energy metric, and that's to drive overall building energy efficiency. We're going to keep our backstops, so these are our minimum standards for fabric and our minimum standards for building services efficiencies, but we're going to uplift both of those a little bit, and you can see the proposals in the consultation. We're also considering introducing a brand new metric alongside primary energy that's affordability. So we already, in the national calculation method SAP, it estimates running costs, and we're thinking of using that estimate to make sure that bills are really low in new homes. So the idea behind this is to make sure that if you're using electric heating in a brand new home, such as direct electric heating or heat pumps, that it's really good for the consumer. And in the consultation, we asked for views on where this level should be set. Let's go through a couple of examples. So these results are all can be made by using the new consultation version of SAP, which was out for the consultation and we've left live so people can keep testing their building designs. So this building here is a 2013 home, but with a gas boiler, and we tested it against the 3 different metrics. So as you can see, it fails on CO2 emissions, it fails on primary energy, and it's got an EPC band of round B. So to meet this 30% uplift we're proposing for 2020, in the consultation we proposed that you could put in some solar panels, PV panels, and wastewater heat recovery. That still won't get you all the way to these two 30% uplifts. So you'd also need to put in some fabric measures, and probably if you put in some slightly better windows, slightly better roof, that'll get you all the way to this 30%. And it's an EPC band B, so it's likely to be okay for affordability. Let's look at this with a heat pump instead. So this is a 2013 home. Get rid of your gas boiler, put in a heat pump. It passes CO2 emissions quite comfortably, but it fails on primary energy. So you're going to make a 19% improvement on your primary energy and get to only an EPC band of C. So meeting 2013 fabric standards and just putting in a a heat pump is not going to get you there. You need to do quite a lot more to meet this primary energy standard. And depending on where we put the affordability metric, it might not pass on that either. I'm going to say a couple of words on transitional arrangements. So when we make changes to building regulations, we recognise that industry needs a bit of time to adapt to these changes, particularly if they're fairly major changes in the way we construct buildings. So we historically allow a period of transition before householders have to adopt the brand new standard. And like I said, it's for a really good reason, but in the past this has led to some housing developments being built to quite old standards. There are examples right now of housing being completed to 2006 standards, and that's not right. That's not the point of transitional arrangements. So to prepare us to get to the 2025 standard and to transition there quickly, we're proposing a more stringent set of transitional arrangements. So those transitional arrangements we laid out in the consultation, and the proposal is that they will apply only to individual buildings, so individual homes on site, and also that they'll only apply when building is started within a reasonable period. And we consulted on what we think a reasonable period is, and we've had some really helpful feedback from the house building industry on what they think reasonable means. So this is the first time this has been proposed for any building regulation. We just want to make sure that new dwellings are meeting this new up-to-date standard ready for 2025. This is a national standard for England, and it's a huge step change in the energy efficiency of new homes. It's a consistent national standard across the country, and it's underpinned by significant technical work and extensive consultation. It can't be negotiated away by developers, and neither does it rely on carbon offsetting schemes. So in the consultation, we've explored some options for what role we think the planning authorities might play in the future. So have a look at that as well. We've received quite a lot of feedback on that. It's been quite active, people's views in the national press, and we're looking forward to having a look through the consultation responses and understanding what we might want to do in that area. So very briefly, I'm just going to tell you about a couple of other things in the Future Home Standard consultation, just a bit of a plug. So it wasn't just about energy efficiency. It was also about ventilation. So we proposed some improved standards based on latest evidence. We proposed to improve the air tightness testing regime, to open it up to innovation and make it a bit more independent. We also proposed some ways of improving build quality, reducing the performance gap, making sure that homes perform really well in practice and not just on paper. And then we also committed in that consultation to another one. So look out over the next few months, there's something else coming. The next consultation will include overheating, which I know is a topic close to many people's hearts. It will be about energy efficiency in new non-domestic buildings. It will be about energy efficiency in work to existing buildings, both non-domestic and domestic, and also ventilation standards in non-doms existing homes. So there'll be quite a big next consultation coming that you should look out for. I'm going to tell you a couple of very brief things about overheating because it's so heavily linked to housing. So we put out some research alongside the Future Home Standard. I recommend that you have a look, and it tells you a bit of, maybe give you a bit of an idea about where we might go in the future. Kind of showed that overheating isn't just a London issue, it isn't just a southeast problem, and there's overheating occurring all over the country. Particularly at a time when we're increasing energy efficiency standards, summers are getting hotter and more extreme. We've got an ageing population who are spending more time indoors. Overheating becomes really quite important, and we'll be addressing this in our next consultation. Just very, very briefly as well, because it launched this week and I should really say something about it. On the Buildings Mission, the government are looking beyond 2025, considering what technologies will be available in the future, and also considering the issues of an ageing population alongside climate change and energy efficiency. And that's why this week government has launched the Home of 2030 design competition. So it's been created to drive innovation in the provision of affordable, efficient and healthy green homes, and there's a £40,000 prize awarded to all shortlisted entrants. I believe that the people that are that win, so there'll be 3 winners, they'll get to work with Homes England and look at maybe developing some of these homes, so it should be really good. And the idea is to showcase best practice and start normalising these sort of interesting future-looking designs that are good for the environment and also suit an ageing population. So just in summary, we've consulted on the Future Home Standard. I've set out how our consultation proposals are really a massive leap forward in energy efficiency and carbon performance of new homes, and this consultation is now closed. It's going to take us a little while to get through all of the responses we received, over 3,000, and we'll respond in due course. So this is a bit of a roadmap to the future, and thank you very much. Look forward to your questions at the end.
Thank you very much, Victoria. I really appreciate your coming along, and I know the Part L consultation has stimulated many, many conversations and now lots and lots of responses, so I'm sure we'll get some questions on that later. Right now I'd like to move on to our next speaker, who's Tom Dollard, who's an architect, head of sustainable design at Pollard Thomas and Edwards, and Tom's going to talk about some examples from the BEIS Building for 2050 programme, which he's one of the lead assessors on. Thanks, Tom.
Thanks, Lynn. Hi, everyone. I'm Tom Dollard. There's all details. So I'm working with my company, Pollard Thomas Edwards, and AECOM on this project for BEIS. It's called Building for 2050, looking at low carbon, low cost housing. How do we upscale low carbon housing for the future? I've got a very short film that we produced to introduce the project. We're working on a longer film that will be issued next year.
The UK government and the house building industry are facing long-term housing challenges. The country needs 300,000 new homes each year to meet demand, which is 50% more than the current production. These homes need to be built at an affordable cost and crucially with lower carbon emissions. In 2019, the Committee on Climate Change recommended 100% reduction in carbon emissions by 2050, which was backed by Parliament to set a legally binding net zero target, effectively transforming the UK into a carbon-neutral country by 2050. Heating and powering buildings accounts for 40% of our total energy usage in the UK. By making our buildings more energy efficient and embracing smart technologies, we can cut household energy bills, reduce demand for energy, and boost economic growth while meeting targets for carbon reduction. As part of the move towards these goals, the government has funded Building for 2050 through the BEIS Energy Research Programme, a major 3-year research project set up to evaluate what can be done now to accelerate the shift towards wide-scale construction and adoption of low-cost, low-carbon homes. To do this, low-carbon housing developments across England and Wales are being evaluated from start through to occupation.
We've got an interesting project here which is doing both social research, which means asking people for their views, and physical research, which means testing the homes, seeing how well they're built, and measuring how much energy they use when people live in them, people like you and me.
The team is carrying out detailed interviews and observations of the construction projects and including a wide range of stakeholders, interviewing 100 experts from industry and beyond to find out how best to meet this challenge.
Really excited about our findings, the potential outcomes. I think they have great potential to change policy and actually more importantly demonstrate to industry that these sorts of homes are very buildable, they're cost effective and they're being done now. So why can't we build every new home as a low carbon home?
The project will conclude in 2021 by delivering key research findings and recommendations to find ways to increase demand, improve supply and deliver improved energy and carbon performance across the UK.
as I said, we'll have an update with a lot more detail in a year's time. So if you want to know a lot more detail about the methodology and our findings, that will be available in the next film. So this is I think this is what the film said. Project objectives. There are 7 project objectives. Context. So we've done a year's worth of lit review and seen who else is doing low carbon housing in the industry. Drivers and barriers. What are the drivers, barriers, attitudes and challenges to building low carbon homes? Understanding the occupant experience. So this is primarily a social research project. We really want to understand the attitudes, expectations of residents. The role of technology. So are we fitting the right technologies suitable for residents in these projects? And then improving the build quality. It's obviously, you've got to make sure these are installed correctly and they deliver the desired outcomes. And then the performance gap. I think Victoria mentioned this is a key part of the energy strategy for the UK and actually delivering what you set out to design. And then finally, how do we accelerate large-scale construction and uptake of these sorts of homes? How do we increase supply to the mainstream? So my role is leading on the site review process. So this is just a small amount of what we're doing on site. We undertake about 7 site reviews during the construction process. So we review every stage of the build as it goes along. Then at the end we do some post-construction fabric and service testing. So this is thermography, it's in situ U-value testing, it's tracer gas test, it's ventilation commissioning and testing. And then we have a year's worth of occupancy monitoring as well, across energy and environmental outcomes. And then really the other 50% is all the social side. So we do intensive focus groups with residents before they move in, 3 months into their living period, and then a year after they've moved in. This is an insight into our checklist for sites. So this is the first fix stage. And this is essentially myself and my team going through the SAP, elements in SAP. So this is the ventilation ducting, checking that ventilation ducting is the same as design. And we know from research, previous research, that ventilation and gaps in insulation is a common performance gap. So we're looking for those common performance gaps as we move through the site. Other simple things we're doing on site is checking the insulation is the same specification. We're checking the dimensions of the walls, party walls for example, and we're checking for thermal bypass, so where air moves through the insulation and causes worse performance. Essentially carrying out rigorous quality assurance on that project and marking down where there might be a difference between design and as-built. And then at the end, we then carry out an as-built model based on that project. So we can tell the development team how far off they are in terms of energy performance and environmental performance. And then after it's complete, we've then got this process of monitoring, gathering social views across the whole industry and residents. And we're interviewing more than 100 stakeholders from industry across and outside industry. To really button down on this research question and get some good recommendations for government and for industry. So our final report will be out 2021-2022, and we'll have ongoing dissemination throughout that. So I'm going to spend a minute now. Mostly it's case study methodology, so we've got 4 detailed case studies and a series of smaller case studies as well that we've brought in. But these are the detailed case studies that we're doing all the complete process on. This is Active Homes in Neath. It's part of Pobl, they're the largest housing association in Wales, and they partnered up with the Active Building Centre to deliver Active Homes. Essentially, they are a fabric first, solution first, and then you have TSCs, which are transpired solar collectors, providing a preheat to the heat pump. And then you have solar PV, building integrated solar PV on the roof, powering batteries. So the early stage tests are showing that they are meeting the old zero carbon standard of 100% regulated energy, and they're producing around about 60% of their own energy through the PV and battery storage. It's also an off-site timber frame, and they're working how to kind of produce that in the next iterations to include the window and to include other elements of floors and other off-site technology. So that's the strategy, and this is the Active Building Centre design principles: conserve, generate, store and release. And that's a photo of site progress from last year. They're now due to hand over next month. Second case study is in Corby. It's Project Etopia, and Etopia Homes. It's 47 fully modular homes, and they use a steel frame system. And the steel frame system meets the Passive House requirements. And then in terms of low carbon technology, they have an earth store energy bank in the ground, and then they have a ground source heat pump that receives energy from that interseasonal storage. They have photovoltaic, thermal, hybrid solar array. So they've got PVT panels on the roof that produce hot water and electric. And they obviously have MVHR as well, as they're going down the Passive House route for fabric. That's the diagram of the technology involved. Probably the earth store heat pump is probably the most innovative part of this design. And they're clearly hitting the definition of net zero energy across everything, so net zero across all the primary energy. That's some photos of the construction going on with the steel panels and the mini piles for the ground source heat pump and earth store energy bank. And this system, the four-wall system, has now got certification under the BRE off-site construction scheme. The third case study is Marmalade Lane in Cambridge, and it's 42 custom-built homes. It's a co-housing project. It's been very well covered in the press from the co-housing side, but it's also pushing the boundaries of a fabric-first approach with air source heat pumps and solar PV. So they didn't actually achieve the Passive House standard. They were slightly short on the air tightness, but I think the crucial thing is they set themselves a target for the fabric, which is 35 kilowatt hours, and then they aim to achieve that and modelled it with PHPP. So it's a non-Passive House scheme, but it's kind of learning from Passive House methodology. And it's also using prefabricated timber panels from Trisselhuis and CLT panels in the apartment block. There's a 3D view, and there's a detail from the architect, Mole Architects. And it's just showing how kind of the level of detail, the attention of detail you have to get to if you're doing a high fabric, low carbon home. And then finally, last case studies in London. We're really keen to get a London-based case study just to show a high density, because I think there's a lot of case studies looking at low-dense housing, and it's almost quite straightforward to achieve net zero with low-density housing, but a lot harder with high-density apartments. So this is a 4-story apartment scheme, which could be scaled up to any height, really. And the key technology is an air source heat pump that then ties into a water-to-water heat pump in each flat. So it's fairly standard masonry construction, and that there's certainly a question around about when you're putting in heat pumps, does it allow you to relax the fabric standards? If you're looking at something like the Future Home Standard, can you get away with relaxing fabric, or should that be disincentivized? Because on this project, they put a heat pump in, and without any fabric improvements, they're getting 57% improvement on Part L. That's the heat pump system. It's got a communal heat pump in the basement, and then individual heat pumps in each flat, individual water-to-water heat pumps in each flat. So to summarise, most of the developments bar one are finished now, so we're now in the monitoring period. We've issued emerging findings to our clients, BEIS, and our stakeholder group in government. And now we're looking for wider industry stakeholders to come forward. So we're looking at interviewing them, focus groups, and looking at other case studies to see if we can do a slightly lighter version of POE, slightly lighter version of what we've done on the other projects. Findings and recommendations are due next year, And we're hoping to have some really positive and insightful lessons learned for the industry to be able to show people that you can build low carbon homes now, and it is practical, it is cost efficient, and really there's no reason why we shouldn't be doing it next year. Thank you very much.
Thank you very much, Tom. We're all dying to get that wonderful set of information, so people will be knocking on your door. And also, you omitted to mention your wonderful book, Designed to Perform, which I'm sure has informed your assessment techniques on how to tackle the performance gap and the things to look out for. So we're moving on to our next speaker, who's John Palmer, who's the Research and Policy Director of the Passive House Trust. And John's going to talk about Passive House as a route for achieving zero carbon. Thanks, John.
Thank you very much, Lynn. Good afternoon, everybody. So, net zero. It's easy, isn't it? 65% of local authorities have declared a climate emergency. 75% of them have set a date for net zero. We've declared London's going to be net zero by 2030, plus 19 other cities. So it's pretty straightforward. Let me tell you what I'm going to talk about. I'm going to start with some definitions. I'm then going to define what I think net zero is going to be, how much renewable energy will we need to make that net zero, and what our current standards are delivering. So starting with some definitions, this is a chart from LETI, the London Energy Transformation Initiative, and it's really neat in displaying the difference between embodied energy and operational energy. So embodied energy is the energy which goes into construction, maintenance and disposal, and then operational energy is the energy needed to run the building during its lifetime. Today I'm going to be talking about the operational energy, the yellow bits. Embodied energy is also required to get down to minimal and then offset to get to net zero, but today I'm going to be talking about net zero operational. So, net zero operational. If you're able to, could you stand up, please, everybody? So, if you think that we are able to, and we've got a chance of getting to net zero operational in the built environment for buildings by 2050, then remain standing, otherwise sit down. Okay, a few people sitting down, mostly optimistic, excellent. If you think that we can get to net zero in the built environment operational for 2030, remain standing, otherwise sit down. A few stalwarts left. If you think we can get to net zero operational by 2025, remain standing, otherwise sit down. For new buildings, yeah. Okay, we've got one or three. Right, if you'd like to come up and do the talk, that'd be great. So I think that just gives you a sense of how difficult or easy people think this is, and I just want to explain how difficult I think it might be. So the first point is, should we be talking for buildings and setting the efficiency of buildings, should we be talking about carbon or should we be talking about energy? So if you think we should be talking about carbon, setting carbon targets for buildings for operational energy, put your hand up. Okay, about a third. If you think we should be setting targets in terms of energy primarily, put your hand up. Okay, a bit more. So both, okay, I didn't give up both as an option. But let me explain why what I think. So let's say we've got up there a 1 kilowatt light. If we have that on for an hour, that uses 1 kilowatt hour of energy, yeah? Really happy with that? Quite straightforward. How much carbon does that release? It depends on the grid. Well, if you're a geek like me, you can get your grid carbon app out, which is very handy, and you can see, well, if you were closer, that it's 309 grams of CO2 per kilowatt hour today, right now. So that means that 309, if I left it on light on for an hour, that's 309 grams of CO2 that goes into the atmosphere. And at the moment, gas is the biggest producer at 50%, wind behind that at 12%. What about this afternoon, when it gets a bit windy in the North Sea? What about tonight? What about tomorrow? Do we know what the grid intensity is going to be? Not really. What about next year, when we may or may not have set up some more renewable energy sources in the North Sea? What about in 10 years' time? Do we know? So does it therefore make sense to set targets in terms of carbon for buildings? No. What about energy? My 1 kilowatt light left on for an hour today uses 1 kilowatt hour of energy. In 10 years' time, if I leave that same light on for an hour, how much energy will it use? 1 kilowatt hour. So that's why, when it comes to buildings, we really need to be talking in terms of energy, not carbon. If we talk about energy, the carbon will look after itself. So this is my little model of what is net zero. I'm going to talk about domestic buildings in the main, but this is similar to non-domestic. We've got my heating, which is the biggest chunk at the bottom. Then we've got some hot water, and then we've got lighting. So if we want to be net zero, we've got two choices really. One is we go and live in a cave, we don't light fires, and we don't use any energy at all, and that is indeed net zero, but it doesn't sound too appetizing. Or whatever energy we do use, we offset with energy from where? From the sun, from wind, renewable energy. So we need to offset that energy. So if we've built our house and the amount of energy we've generated from renewable sources matches our heating, hot water and lighting, are we net zero? Hands up if you think we're net zero. A few. Well, no, we're not. And the reason we're not is because that's our regulatory version of how we use energy in buildings. We've forgotten something else which we use all the time in buildings, which is unregulated energy, which is plug loads. So we use appliances, fridges, TVs, etc., etc. So now if we offset those, is that net zero? Any hands up for that? That's now net zero? Oh, I've got one. So no, it's not. And the reason is because we've got to now move ourselves into a future nirvana. And in our future nirvana, be that 2030, 2040, 2050, are we burning any fossil fuels? No, we're not. If we want to be net zero, we're not burning any fossil fuels. We cannot burn stuff. Rule number one. So if we're not burning fossil fuels, where is our energy coming from? Go on, shout out. Same, renewable sources. Okay, what is the main problem with renewable sources? Stops and starts, very good. So World Cup final, half time, does the wind conveniently blow and does the sun conveniently shine? No, it doesn't. So renewable energy comes when it feels like it. We can kind of predict it, but it's not reliable. So what does that mean? That means we have to store it. What's the problem with storage? It's expensive, but what's the real main problem with storage? It's lossy. So if you put 1 kilowatt hour into storage, you might only get 0.9 kilowatt hour out, or 0.8, or 0.6, or 0.5, depending on your type of storage and how long you store it for. So if you have lots of renewable energy in, for example, the summer, sun, and you are only going to be able to use that in the winter when you need heating, that's interseasonal storage, which Tom touched on earlier, which is traditionally very lossy. So that means we've got to store things. That means for my building, if I need 1 kilowatt hour to run it, and I use storage, I actually might need 1.2 kilowatt hours or 1.6 kilowatt hours of renewable energy to actually make it net zero. So that means my actual net zero is not only my heating, my hot water, my lighting, my appliances, but also my storage losses in our future world. So, my column has got quite tall now, hasn't it? So that means that the more I use, the more storage I need, the more storage losses there are, the grid needs to be able to cope with that, and I've got higher peak load, and I need more renewables. So, is that achievable? Do I need a tall column, or a small column, or somewhere in between? Well, let's try and put some context on that. So, how much renewable energy, so I'm talking about my blue column now, how much will we have in the future? So we can look at the National Grid future energy scenarios, and with nuclear power, we are going to get, in the best scenario, just over 400 terawatt hours per year. Is that good? It's quite good. It's not bad. How much of that can we give to buildings? Well, at the moment, if we look at how much energy, divide up the pie at the moment, total energy, 27% goes to buildings. So let's say, for argument's sake, 27% of our future renewable energy goes to buildings. What we can then do is we can work out from the amount of domestic floor area we're going to have in the country in 2030 and 2050, how much renewable energy we can afford to give per metre squared of domestic property per year in 2030 and 2050. So these numbers are around 35 and around 50 kilowatt hours per metre squared of renewable energy is available. So that's the total size of my blue bar. I'm going to come back to whether that's good or not in a moment, but that just gives us an idea of balance, because everybody seems to think that we've got vast amounts of renewable energy and it is limitless, so we can build what we want. That's not the case. So at the moment, we're building to those kind of levels of efficiency. So I've now taken my maroon chart, heating, hot water, electricity, etc., and I've turned it into real numbers per metre squared for dwellings in the UK. Roughly at the moment, with a building regs and gas boiler, we're designing to around 110. We're building to around 140 because we've got this performance gap issue as well. And then if you put in a air source heat pump and low carbon source, but include our storage losses, we're down to about 120. If we build to a passive house level of fabric efficiency, we're down to about 60 with our storage losses, or just over 40 without the storage losses. So that just gives you an idea of scale when it comes to fabric first and low carbon heat. Let's make that more real. I've now turned from kilowatt hours per metre squared to an actual building, 68 metre square building, and this is the total demand over the course of a year. So there is, on the far left-hand side, an air source heat pump with storage losses. Then we put in place a passive house. To get my blue column sufficiently high to offset that and make it net zero, I need 14 solar panels. Okay? How big is a 68 square metre house? Or flat? Very small. It's my 2-bedroom flat, something like that. So are you going to get, and how much space does 14 solar panels take? Quite a lot. Are you going to get 14 solar panels on every 68 metre squared house, flat, building in the UK? No, you're not. So is it sensible, therefore, and this is passive house levels of efficiency, we can't really go much further, is it sensible to try and think that we're going to make every house net zero individually? No. So how do we think about the problem? We need to go back to the whole of the UK and the whole of our renewables pot. And what we need to say is our whole renewables pot big enough to make all our dwellings net zero? Because we can't do it on an individual basis. And buying a quarter of a wind turbine blade in the North Sea is a lot more cost effective than putting solar on every single house. So I've now turned these into different standards, and I've taken out storage losses because that's going to come from the grid. But you can see that the energy use intensity, so this is the amount of energy that goes into the building when it's built to these different standards that is required to run it. Kilowatt hours per metre squared per year. So there we are on our current left-hand side, almost up to 140. 19% reduction, 20% reduction, which is the option 1 from the Partel consultation, brings us down a bit. The London plan, which is supposedly zero carbon, brings us down a bit further. Passive house, low energy building, and then we've got a stab at what we hope the future home standard might be, and finally the passive house classic. So that's where we would be in terms of a continuum of performance levels for different standards. So do you remember those figures I put up earlier? What were they? 2030 was 35, 2050 was 50. Okay, so there they are. Now what do those two lines tell you? They tell you that if every single dwelling in the UK was passive house quality in terms of fabric in 2030, we will still not have enough renewable energy to make the built environment zero carbon. In 2050, if every single house in the UK, not new ones, just new ones, all dwellings in the UK, including existing, were passive house levels or better, then we would just about have enough renewable energy. Are we going to make every single dwelling in the UK passive house by 2030 or 2050? No. It's one every 12 seconds if you want to get to 2030. So, it's a challenge. Takeaways, net zero means the total energy that we use in a building plus the storage losses. We can't ignore them, they have to be taken into account. Current standards, despite what we might think or hope, they're not even close to what we need to be in order to get to net zero, given the current projection for renewables. And even with Passive House Classic, which is the predominant fabric-first standard, it's not easy. There's 14 solar panels. As I say, every house in the country still doesn't give us enough to get to net zero, but all this is made worse if we're building fabric inefficient houses from now on in. So every house we build that is not of the maximum fabric efficiency, and when I say maximum, I do mean passive house or better, every house we build which is not to that standard is making the problem worse. And we're going to have to retrofit those houses in some point before 2050 if we're going to get to net zero. That's it. Thank you very much.
Thank you so much, John. That was dynamite and a timely reminder of the big picture. So our last speaker is Professor Fionn Stevenson, who's a professor at the University of Sheffield School of Architecture, is an architect, and she's talking about housing fit for purpose, a best practice approach to post-occupancy evaluation as feedback for design. And funnily enough, I think that's the title of your most recent book, Fionn. So, thank you.
Hello, everybody. This is going to be a bit of a shameless plug for my book, so I'm sorry about that. But I hope for the next 15 minutes, if my voice doesn't give out, I'm going to explain why it's not good enough to just design and to just model. We actually have to test our homes in reality. And that, for me, is the bit that is missing from the new future housing standard, is that we do not have post-occupancy evaluation in it. So I'm going to crack through the next few slides fairly quickly because I think these will be familiar to a number of you. We've got our Climate Change Committee in the UK saying that our 29 million existing homes need to achieve what John has just talked about. And this is the dream. This is what everyone sitting in this room aspires to, which is the new 80% reduced energy efficient home with bells and whistles on it, everything we want. But this is the reality of most homes in the UK, particularly new homes. The reality is we have situations like, and I hope I'm going to get the, doesn't work, it's broken. Not the TV anyway, something else. Well, the reality is on the left-hand side, you have occupants desperately trying to ventilate their home which has no cross-ventilation. The reality is we have here a filter for a top-of-the-range, mechanical ventilation extract system. It's never been taken out. It's never been cleaned. The occupants didn't even know it was there to be taken out, and the housing association didn't realize it was their responsibility. These are some of the issues we're facing well beyond any demands for new standards. And of course, then we've got silly little things like pipes not being properly insulated. And this is the reality as well. This is the triple hurricane that housing causes. This is the climate emergency. This is why we're all sitting here today, is the fact that housing is responsible for up to about 1/4 of carbon emissions in the UK. And literally, housing causes hurricanes. And yes, we have 4.5 million homes overheating now in the UK. So it's far too late for the government to be talking about addressing overheating in the future. It's now. And yes, we've got 5.5 million people suffering from asthma in the UK. These are in homes that are not performing well because they've not been tested. So here's the challenge I put to all of you today. The Climate Change Committee has demanded greater levels of inspection. The Climate Change Committee has demanded that the government does as-built performance of our homes, that the new housing standard mandates the measurement of how much energy our homes are using, the measurement of the air quality inside our homes, the measurement of how our fabric's performing. That is not in the new proposed housing standards at the moment, and it should be. And why? Because we know that homes routinely underperform, often using at least twice as much energy as they're supposed to use. And that's not just Wimpey and Barratt and Crest and whatever else. That is the architect-designed homes as well. The only homes that really cut it consistently are passive house homes. So, the shameless plug for my book, and I'll whiz through this very quickly. It's on sale at the RIBA bookstall, but that'll probably be closed by the time we get to the end of this talk. Anyway, this is the first of its kind. It's a go-to how to do it in easy steps, how to make sure you know what your home is really doing, whether you're a designer or an occupant. It's even got a primer in it, a simple bit at the back of it. And what's new about this approach is that it looks at everything that was talked about in the previous talk, everything that Tom Dollard was talking about. It takes a socio-cultural approach. It talks about ethics, the ethics of housing. It talks about education, so desperately needed. We don't teach post-occupancy evaluation. We don't teach it. It talks about the cost of doing this, which you all want to know about. And the great thing is the book is directly aligned with a fantastic initiative by the RIBA, a free download called Sustainable Outcomes Guide. Brilliant document, just launched a few months ago. I urge you all to read it if you've not read it already. So the key questions are our homes doing what they're supposed to be doing physically? Are we happy with them? Are there any problems? And what can we do about that? And the real parameters that we need to be looking are, we need to look at the hard data that Tom Dollard was talking about. We need to measure some things. But crucially, as he said earlier, we need to understand what the home is like to be experienced. What are we actually going through in our homes? What are we experiencing? And do you know what? Most architects don't know what the occupants of their designed homes are actually experiencing because they don't go back to find out. And why don't they do that? Because they don't have to. It's not mandated. Then we analyze all of that, and we can actually build better homes. Not only can we build better homes, we can actually make sure our homes are future-proofed for the climate emergency. But how do we get this happening on a mass scale? This is the problem. Here we've got the house builders saying, even if they did understand the mechanics of the business, they didn't understand. They wanted to go in there and cover everything in kit and do it for 10 years and take data every 5 seconds. Post-occupancy evaluation doesn't have to be like that. You don't have to start there. It can be really simple, and that's something the government needs to understand as well. POE is simple. You don't monitor the routine things, you look for what's misbehaving. That's what's important. So the 6 key things which Tom touched on earlier is, first of all, review the actual design documentation. Secondly, do a very quick audit of how much energy the home's using, how much water it's using. Then use one of these fantastic gadgets called a thermal imaging camera to see whether or not your insulation's working. Finally, ask the inhabitants, because they know better than the architects about what's actually happening in the home. Then do a short tour. Get the architect together with the builder, that would be a first sometimes, and the inhabitant, that would be a real first. Get them all together, walk around the home, find out how it's working. Do a quick spot check. And look, no sensors yet. No sensors yet. If you haven't got one of these in your architect's offices or your engineer's office, shame on you. These are X-ray specs. You can buy one for 200 quid and plug it onto your iPhone. I used it on my own house. I showed my builder a big blue patch in my ceiling and said, look, you've missed out the insulation in my ceiling. And he said, fair cop. And we got the job done. Also, inhabitants are actually very good at monitoring their own homes if you give them the right kit and the right opportunities. So the external monitoring only needs to happen once we've educated inhabitants how to look after their own homes. Of course, we may need to delve deeper, and that's what Tom Dollard's great project is doing. You may need to do deeper monitoring, but don't start there. And there is an obvious case for POE, and why on earth has it never happened? These are all the advantages of when you do it. You improve your product, housing developers and architects. You improve your process. For the insurers in the audience, for the people living in the homes, POE reduces the risks that are hidden in your homes because it exposes them early on. And that's actually a win-win. Better to know what's happening now than what's going to happen later. You get reduced defects because you find them and you address them. Reduce maintenance because you improve your performance. As I said earlier, you can future-proof. You can find out that the home's overheating and what to do about it. But best of all, if you do POE and you improve your quality process, you get better satisfaction all round. And that, of course, means you get a better reputation, which means that as architects or developers, you get repeat business. And isn't that what our government wants? Doesn't our government want better business? So why is our government not mandating POE? The RIB have already endorsed it, they've endorsed the book. But where is the government? And where is the housing sector on this? Well, there are some challenges. Doing post-occupancy evaluation does have ethical implications. You're dealing with people's personal data. So if you read the book, you'll understand how to do that safely. It's not taught. Why is it not taught? Because it's not mandatory. It doesn't need to be taught. One of the things that we've seen today is a lot of housing developments which have got a lot of innovation on them, a lot of technologies. We've got heat pumps competing with PVs, competing with solar thermal, with interseasonal heat store, goodness knows what. Keep it simple. That's what we need to do with our homes. Reduce the demand, keep it simple. POE, when I carried out 23 studies in the year 2000, 23 social housing studies, POE, the problem time and time again was too many technologies. Yeah, too many. Monitoring. We need to be aware, if we do monitor, we haven't sorted out that monitoring is future-proof. Yes, your dog could eat the sensor. And then the blame culture. We need a new contractual blame culture. We did it with the Olympics. We had the best contract in the world with the 2012 Olympics. Again, government endorsed. Why is the government not promoting the Olympic contract for housing so that we have a no-blame culture? Where is the government leadership on that? Where we are getting leadership is with wonderful organisations like Letty in London, who've produced, again, a free, fantastic download guide. Read it if you haven't read it already. This is how to design housing for the future. And they do give you the process as well for how to do POE, so thoroughly recommended. So I've just got 10 urgent questions for the government today in relation to our future housing standards 2025. I actually thought 2025 meant that's when we were going to get the housing done by. Now I realise it's actually when we're going to get the standard out. Well, if we're going to get the standard out in 5 years' time, let's get the following sorted. First of all, how will this standard verify housing performance? How will we know that our housing is doing what it says on the tin? Because at the moment, the standard doesn't guarantee that at all. It might do some measurements at point of completion, but it's not doing any post-occupancy evaluation. How are we going to engage the inhabitants in our homes? How are we going to get them on board with this new standard? It's no use just getting the architects on board, or the engineers, or the developers. The bottom line here is we need to work with the people in their homes to make this work. And how is the government going to make sure that POE is built into the construction process using the soft landings approach, which it took on originally and has now dropped? Why has that been dropped? I don't know. And how are we going to scale up POE so that instead of just 19% of architects offering it as a service, we have 100% of architects offering it as a service? And how is the new standard really going to ensure that homes are environmentally sound, not just carbon neutral or anything else like that? How is it going to ensure low toxicity? How is it going to ensure low embodied energy? That's not even in the new standard. Nothing about low embodied energy or low embodied carbon. Fatal flaw in the current standard, which is why they've had 3,000 responses. At least half of those have argued for embodied energy to be included. And how are we going to develop the right criteria for post-occupancy evaluation? You can read my book and judge for yourselves, but we're not even having the conversation with the government about this in terms of homes, when we should be. And why do we not already have MOT checks for our housing? Cars have that every year. We have a car culture. You wouldn't think twice about getting an MOT done. But your home doesn't have an MOT ever, apart from when it's handed over. Maybe the boiler, yeah? But when does the fabric get tested? Imagine driving a car and your door was falling off. I did do that once at Greenham Common. But you know, imagine you're driving a car and your door's falling off. It's not going to pass the MOT. How many millions of homes have we got where the insulation's not properly fitted? So, all of this is really for me to say that if we don't regulate POE, we are never going to get zero carbon housing in reality. We're going to get it on the paper, but we're never going to get it in reality because we have no feedback. And it's the feedback that will improve the process. We need that feedback loop. And it's only when we get that feedback through understanding how our homes perform that we will really be able to tackle the climate emergency for real rather than in theory with standards. And at that point, we can actually look forward to a standard that offers a real performance guarantee rather like Energy Sprong. So, a quick whiz through, and POE is vital for homes that are fit for purpose. Thank you.
Brilliant, Fionn, thank you so much. I think we've probably got loads and loads of questions and we've got a few minutes, so can I ask speakers to come up? As another comment really for our questioning, I was at the launch of the Home of 2030 this week with the new housing minister, and he himself said 2020 is a key year in tackling climate change, particularly with COP26 in the autumn, and that he's going to visit Goldsmith Street in Norwich ASAP, and the government wants to see all new homes that improve environmental standards. So from what you've heard today, I'm sure there are some burning issues for our speakers. First of all, Thomas, have we got a mic? Yeah, thanks. And then the lady there.
Thank you. I'm Thomas from Etude.
Say who you are and make it brief if you can, please.
Yeah, so it's Thomas from Etude and Letty. So it's a question for you, Victoria. But firstly, I want to say it's great that you come to these industry events. It's necessary, but it's also very brave of you. So thank you for coming. The two questions now. So one on Part 2020 and one on the future home standard. On Part 2020, can you say a bit more on the consultation and the timescales within which you're hoping to feedback? And on the future home standard, there has been great presentations from the other speakers, and it seems that there's a degree of consensus over what we need to do, which is much greater than it has ever been. Why do we have to wait 4 years until we see the future home standard?
Okay, can you hear me? Yeah, okay. So on the 2020, when it's coming, soon, It's coming soon. Because of the volume of responses, we only have limited resources to try and get through these responses, understand what people have said to us, and then develop the new policy. So it's going to take us some considerable time. But you can expect it soon, and there'll be this new consultation soon as well. That's all I can say on that one. On 2025, how long it's going to take. So I think I said a bit in my presentation about what the point is of the 2020 step, and we're really keen to do this 2020 step so that it supports the 2025. I recognise that there are many people in the room who are already on board and can already do this stuff, but most of our industry cannot. And most of our industry are not geared up to deliver heat pumps. Like I said, we've got 800 installers ready to install heat pumps. We really need that time to ramp up industry and make sure that they're ready, the whole of industry. This isn't just a few people who do this. The entire industry who build new homes need to be able to do this stuff. And it's going to be quite difficult for them, and we need to give them the space of these sort of 4 or 5 years to get ready to deliver it, because we need them to deliver it really well straight away. There's no point in us putting this in really soon, and then industry not having the right skills, us not having the right supply chains, and then making a bad job of it, which will in turn mean that consumers of new houses who on the whole are not interested in energy efficiency, they're not interested in climate change, they're interested in whether it's near to a good school. That's their real interest. They will be the ones that will experience heat pumps, and then it will get a bad name among the rest of the country. We need to get this done right the first time.
Thank you, Victoria. We've got 2 more questions here. Can we speed up if we can?
Hello, my name's Joe Giddings. I'm from the Architects Climate Action Network. We were working to generate as many responses as possible from architects in the industry. One of the things we were asking for is embodied carbon to be included in the Future Home Standard. Because if declarations and reductions of embodied carbon are mandated by regulation, we think this will ripple down through the economy, requiring a lot more from suppliers and industries that are currently producing a lot of emissions. So we were quite disappointed to hear yesterday from your colleague Peter Rankin, who stated that the conversation with embodied needs to start at the product level, then we can talk about buildings. Frankly, I think this is actually a bit of a cop-out and a dereliction of duty. Given that we're in the midst of a catastrophic climate emergency, why is embodied carbon not written into the Future Home Standard now?
And can we take the second question, please, so that it's not all on Victoria, hopefully?
Hi, I'm Phil Bixby. I'm an architect and passive house designer. Unfortunately, this is aimed at Victoria as well. I take the point that some of the technologies are novel and require a lead time, but a lot of the issue in the construction industry is simply poor quality construction that fails to do what it should do. We can address that now and say if the Future Home Standard and indeed the 2020 standards were about fabric efficiency, we could make real changes immediately.
Thank you, Peter. So, Victoria, will you take that, and perhaps one of our other panellists as well? Can you respond to the perhaps your... So 2 questions, one on embodied energy, one on quality of workmanship. Would you mind talking about, have you anything to say on embodied energy, Victoria?
No, not really.
It's a
So
done deal. Yeah.
Peter Rankin already spoke on Tuesday, and so he sort of gave the answer. It would be an enormous challenge to start dealing with embodied energy. It's not one that we put into the Future Home Standard consultation that just came out, but it is one that we are taking very seriously. We have heard what people have said in the responses to the Future Home Standard, and we are going to take it seriously, and we will respond. But right now, we haven't read all the responses to know what we're going to respond to.
Okay. Tom? And
Yeah,
then
from
Fiona,
what I've
briefly,
heard
if you will,
from-
we'll take another one.
From conversations with BEIS is that they see embodied carbon as a separate issue that should be dealt with through industry, so the supply of materials rather than the demand. So basically, buildings shouldn't have to calculate that, they just look at operational, and embodied carbon is dealt with through the manufacturing industry, the supply industry, which is a neat way of being very clear about how you deal with it, but the problem with that is it doesn't deal with the demand, so there's no demand. If we had the standard for embodied carbon within something like Future Homes, or perhaps like UK Green Building Council is suggesting, you just have two parts of net zero, so you just split them down the middle, one's embodied, one's operational, but we need it in there as policy, because otherwise it won't drive demand for manufacturers to produce this materials.
Well, and one of the key strategies is to do more with less material, actually.
Absolutely.
So, Fionn, yeah, sorry.
Yeah, I just want to come back to government on the need to improve our our construction workforce capacity to build better quality housing. Actually, we need leadership there from the government too, because what that comes down to is education and the fact that our vocational education training courses at the moment are short, and they're not structured. I mean, if, for example, if you look at Germany and the German culture towards construction, where construction works, that is because the government works with industry and works with the education providers together to actually have a very structured, well-organized vocational training program. And it's true, if we were to just throw ourselves into these new technologies without people being trained up properly, we will just continue the dissatisfaction vicious circle that we're in at the moment with housing performance. So I do think there's an additional role for government to take on, which is to be show much greater leadership in terms of vocational training.
Thanks, Fionn. John, do you want to briefly comment on that? Because obviously Passive House is a growing culture of quality in construction, but it's still seen as a niche issue. So how do you perceive it, that issue?
Yeah, so I think there's two separate things. There's the technologies, and there isn't really that much new technology that goes into a passive house, MVHR, which actually is quite widely used, especially in the southeast, triple glazing perhaps, and then better quality construction. But what I would say is I absolutely agree with Victoria that we need to give the industry time to get ready. We need to signal, signpost, so that things like the triple glazing industry in the UK, which is still very small, can gear up. MVHR designers, as well as the supply chain, etc., can get ready. But at the moment, the timeline that's been set out for the Future Home Standard sees us consulting, I think, in about 2023, 24, before in announcing in 2025. At that point, we will get the response from the house building industry, which is, well, we're not ready. You haven't given us time. We haven't been able to gear up because you've only just told us that we need those technologies. We now need to tell the housing industry right now, within the next 12 months, exactly what's coming in 2025 so that they are ready. Otherwise, they won't be, and we'll be back to square one.
Thanks. One last question, please.
Hello.
Lady, is it a lady? Sorry, no, guy in the middle.
Could each member of the panel give one example of how the passive house route to the achievement of Future Home Standard could be achieved, and how that can be achieved by incentivising the development industry to take that route rather than the route that the government are currently going down?
Well, John, I think you should take that one first. Be brief if you can.
I'll go first because then it's easier for me. So I think there's one avenue which we could explore. It's actually within the gift of local authorities at the moment, and that is to have a variable CIL rate, Community Infrastructure Levy. So and we're seeing things like this in other parts of the world, Vancouver and Brussels and things, whereby if you decide to build a code house, a building regs house, you pay the full rate of CIL, £200 or whatever it is per metre squared. If you decide to build a passive house, you only pay £100 per metre squared of CIL or £50 per metre squared of CIL. That's a genuine financial incentive for developers to build to higher energy efficiency standards, which they can choose to do and which local authorities can choose to offer, which doesn't affect anything else.
Thank you. Tom?
I think the feed-in tariff was really successful, so something along those lines, a metre squared rate for building passive house would be really useful. Vancouver, Brussels, they've done that. I'd just like to deal with a slightly separate question. Well, perhaps I'll leave that for summing up. I think passive house is the best way of delivering net zero, quite clearly, but all the wider benefits as well around acoustics, security, comfort, everything, indoor air quality, environmental. So how do we incentivize that? And I'd actually push it back to this room, not necessarily government, because I don't think it's actually government's job to incentivise this. I think they set the minimum targets, the minimum standard, yeah? That is going to be the Future Home Standard. It's then up to us as an industry and good clients, this is where we need good clients, good architects to say, I want to go beyond that. I want to go to Passive House, which I think and I believe is the best way of delivering beyond that standard. So should Passive House be the Future Home Standards? I'd say I don't think you really struggle to get that, but should clients be delivering more Passive Houses? Yes.
So I'm going to have a bit of a disagreement among the panel. I do think we need to see more government intervention in the UK. You know, we're talking about a wartime situation here. You know, we are in a war. This is the climate emergency. We've looked at what industry's done in terms of voluntary schemes over the last 30 years. The biggest government intervention that happened here for housing was in 1979, when everything changed with Maggie Thatcher and we had the big house sell-off, yeah? That was a major government intervention. We now need a similar kind of government intervention in reverse, where the government says we are in a climate emergency, we need to put the housing industry on a war footing, and yes, we do need to make some pretty tough regulations. And one of the regulations I'd introduce, I'd introduce mandatory post-occupancy evaluation. But secondly, I do what they do in the Netherlands very successfully. And I do wish our government would look more to the EU for best practice. I would do what they do over there in the Netherlands, which is introduce a performance guarantee for housing. Now, there's a hell of an incentive that's just beginning to dribble through here in the UK. Why can't we do more of that?
Well, on that note, I think we unfortunately have to close the session unless any of my panellists has a last word to say.
I think what they also do in the Netherlands and Belgium and the EU is they have energy assessors and architects on site because of that. So we've completely lost that. And the great example that everybody's seen is the Goldsmith Street project. That was a traditional contract set by an ambitious client. So my point about the client is massive. They set a traditional contract where the architect was on site every day, looking at quality assurance, not just the Passive House side of things, but everything in terms of aesthetics, maintenance, all the rest to deliver better construction quality. And the EU, most European countries apart from us, are way ahead of that. So that's something that maybe not just the Future Home Standard, but the whole of building regs needs to look to.
I'd just very quickly like to put some figures on Fion's war footing. At the end of the Second World War, the UK was spending 50% of its GDP on the war effort. At the moment, we spend 4.2% of our GDP on defence. If we spent 4.2% of our GDP on retrofitting houses, we'd have them all done by 2030.
Okay, please join with me in thanking everyone who's spoken today. Thanks a lot.